Picture this. You're sitting in your Cambridge 9626 IT exam. You flip to a 6-mark system software question, and you confidently write down what you think is a totally foolproof one-sentence answer with minutes to spare. You write, "A compiler just translates code." Honestly, if I asked 100 IT students right now, a staggering number would write exactly this. It sounds right, doesn't it? It's simple, direct, and yeah, technically, a compiler does translate. But for Cambridge, that answer gets you exactly 0 marks. Nothing. Nada. It is a massive loss of points right out of the gate. It completely lacks the technical precision and depth examiners are actively hunting for. It's exactly the kind of subtle trap that silently destroys grade boundaries. But stick with me, because by the end of this explainer, you are absolutely never making a mistake like this again. Section 1. Translators, compilers, and interpreters. All right, to fix that terrible 0-mark answer, we gotta establish our baseline. System software isn't like the web browser or game you open up. We're talking about the core programs that run and control a computer's hardware and application software. Think of it like the absolute vital infrastructure of your machine. Before an app can even breathe, system software is already there managing the resources. And a huge part of that job, translation. You already know, computers only understand machine code, those ones and zeros, while we write in high-level languages like Python or Java. We desperately need a bridge. And that brings us to our first major player, the compiler. A compiler is a program that takes statements written in a high-level language, which we call source code, and converts them entirely into machine language or object code. Now here is the critical part you need for the exam. It translates the whole program as one single unit in one go. Once it's finished, it spits out an executable file that runs independently. The compiler isn't even needed anymore. But if there's a bug, the compiler only gives you a list of error messages after it's tried to translate the entire whole shebang. On the flip side, we've got the interpreter. So while a compiler swallows the whole program at once, an interpreter translates that high-level language program just one statement at a time. It takes a single line, turns it into an intermediate form, and immediately executes it. And here is why programmers love this. It keeps doing this line by line until it hits the very first error, and then it just stops completely. That makes pinpointing exactly where your code broke incredibly easy, which is a massive game changer for debugging. Now, this breakdown is pure exam gold because examiners love asking about these exact trade-offs. Since interpreters translate line by line on the fly, they're generally slower than compiled programs, which just run all at once. But compiling a massive program eats up a ton of memory because the whole thing has to be loaded first. Interpreters, they save on RAM since only a few lines are in memory at any given time. Oh, and one more thing for your exams. Compiled programs hide your original source code, protecting your intellectual property, while interpreted programs need the source code sitting right there every single time they run. Section 2, the high-mark answer framework. Now, in just a moment, I'll show you the exact examiner clue that changes how you answer exam questions completely. But first, you absolutely need the framework that makes that clue obvious in the first place. Enter the PLJ framework. Just memorizing facts about compilers is only half the battle. The other half is actually proving it to the examiner. PLJ stands for point, evidence, explanation, link, and judgment. When you face a heavy 6-mark question, do not just brain dump facts. You make a clear point. You back it up with evidence or a technical definition. You give a rock-solid explanation of how it works. You link it straight back to the question's scenario. And for the highest tier, you drop a reasoned judgment. Check out how brilliantly this transforms our flawed, cold-open mistake into a top-band response. Instead of that weak, a compiler just translates code, look at the upgrade. A compiler translates whole source code. Boom, that's our point. Producing object code. There is our evidence of technical vocabulary. Making execution faster since it runs in one go. That is our explanation. Just like that, a totally 0-mark disaster transforms into a guaranteed high-mark win. Section 3. Connecting code, the linker. So once your code is compiled, you're done, right? Not exactly. Modern software is almost never just one giant file. Let's do a quick active recall test. Take a look at this student's definition. A linker compiles the modular program into hardware. I want you to pause for a second, try to spot the absolute fundamental errors in that sentence based on what we've covered so far. Did you catch it? A linker definitely does not compile anything, and there is no way it turns software into physical hardware. Here is the examiner-style correction you need. Real-world programs are written in modules. Basically, separate chunks of code written by different people to save time. A compiler turns those separate chunks into object files. The linker is the crucial system program that steps in right after to combine all those separate object files into one single executable file. And examiners are going to test you on the why. Why even bother using a linker? Well, writing in modules means a massive program can be compiled in small, manageable parts. That is huge because it uses way less RAM than trying to compile a gigabyte-sized program all at once. It saves resources and money. But the catch? The main disadvantage you need in your notes is the risk of variable conflicts. If two programmers accidentally use the exact same variable name in their separate modules, the linker gets totally confused when stitching them together. You need incredibly strict documentation to avoid that mess.
Section 4. Device drivers and operating systems. Okay, let's escalate to the final, most complex layers of system software. We translated the code, we linked the modules, but how does this software actually talk to your physical mouse or printer? Enter device drivers. A device driver is a small program that lets the operating system and your apps communicate directly with a piece of hardware. The source material has a literally perfect analogy for this. Imagine a Spanish speaker trying to talk to a French speaker, but neither knows the other's language. Total silence, right? But hand them a translating app and they communicate perfectly. Your word processor speaks software. Your printer speaks hardware. The printer driver acts as that real-time translator, so your essay actually prints. Without it, the hardware is just an expensive paperweight. And sitting at the absolute top of the food chain, orchestrating this entire digital symphony is the operating system, or OS. Once the BIOS boots up the machine, the OS takes over this massive rapid-fire juggling act. It allocates exact blocks of RAM. It manages the constant flood of input and output data. It handles exactly where every single file is stored on the disk. It slices up tiny fractions of CPU time so you can listen to music while typing, creating the illusion of multitasking. It throws up those error messages when things crash. And, crucially, it handles system security, immediately encrypting your passwords so they are never just sitting there as plain text. Section 5. The examiner's final verdict. All right, let's bring compilers, linkers, drivers, and the OS all together for one final high-stakes exam scenario. Look at this beast of a question. Evaluate the role of the operating system in maintaining system security. Using that PELJ framework we learned, you know exactly what to do. You make points about password encryption, you drop evidence about storing calculated results instead of plain text, and you explain how it locks down file permissions. You've got the knowledge locked in. But guys, there is a massive trap hidden in plain sight right here. Even with absolutely flawless knowledge of the OS, if you miss the true meaning of the very first word in that question, the command word evaluate, your grade is automatically capped. Evaluate demands a very specific type of response. It requires a judgment that goes way beyond just describing or explaining things. Misunderstanding this one word is the hidden cause of lost marks for literally thousands of capable Cambridge students every single year. So how do you actually decode these command words to unlock that top mark band? Well, that is a whole different beast, and it's exactly what we are going to solve in our next explainer. You have to know this before your exam. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Click the video on your screen right now to master those command words, and I'll see you over there.